go over the theory with the other class. If you really want to see it, we'll go back and see it. I did with the other class go over something tough first, and I lost them. So I'm going to go do something simple first with you guys, and then we're going to go to tough that way. I did that because students who hate math that take a course and then write a little survey told me that they hate, one of the reasons they hate math is teachers give them easy problems on the board and then they give them hard problems on the test. So I thought, well, maybe I'll switch the order. I'll do the hard thing first and I make them do something easy on the boards. Didn't work out well last class. So let's do something easy first. This is chain rule, but more than one dimension. And by the way, everything's recorded and it goes on a YouTube channel so you can see when you're doing your homework exactly what we did in class. The kind of problems that you're going to see is something like this. You'll get two formulas. So it's parameterization now with two letters instead of one. And you are asked to find things like the partial of z with respect to t. That's the kind of task you have. And you're asked to do it two ways. I'm going to do it the non-intuitive way. And then I'm going to ask you what you think would be the other way. And I did it the other way growing up, and I ended up with a B+ in the class. So you can get away with doing it one of the ways, but it looks like Stuart's problems that you have on WebAssign make you do it both ways. So can't get away with that. So how do you do this? Step one is to compute the derivative from left to right. They also said my handwriting was bad, so I'm going to try to write neater. It's nice to have a class right before yours, isn't it? That I mess up in and I can get it right the second time. So from left to right, the derivative of z with respect to t is equal to the derivative of x squared. That's like the easiest thing you learn in Calc 1. What's the derivative of x squared? 2x. I taught my son how to do that when he was a little 2-year-old. Say the derivative of x squared is 2x. And then you have to multiply by the inner derivative. So you take the derivative of x, you multiply by dx to t. Because x itself, that's the inside. X is a function itself. And this is where the chain rule comes in. You're taking the multiplying by the inner derivative. That's what you're doing. And then I have the second part of this, the y squared x. That's a product. So you have to use product rule. And everybody says, Dr. T, we do it the opposite way from you. I learned it with words. First times the derivative of the second plus second times the derivative of the first. The formulas in the books are the other way around. Doesn't matter. Order doesn't matter. Y squared plus the derivative of x times the derivative of x. What's the derivative of x? Just with 1 by itself. So I'm going to put a 1 there just so you know where it came from. And then because I just took the derivative of a function, I have to multiply by the inner derivative. And then I do second times the derivative of the first. What's the derivative of y squared?
2y.
2y. And then I just took the derivative of something. What should I multiply by? You got it. Maybe it wasn't me. Maybe the other class is just a little bit slower. That's going to be on the YouTube video. They'll hear me. Okay. Got it? So where does everything come from? I'm just going to put some arrows, not all of them. Yes, it is. Yes. Implicit differentiation is also just chain rule. That's exactly what it is. Multiply by the derivative of x with respect to t. So I left out with respect because I ran out of room. Okay, any questions so far? We got some more steps left. So I just want to make sure you understood up to now. Good? All right, so step 2. If you notice here, I had 2 things. I had this guy and this guy that I don't have formulas for. So I'm going to find them. Find the partial of x with respect to t and the partial of y with respect to t. Where do I get those? From the formulas on the top. So partial of x with respect to t is equal to s. Why? The s is like a number. It's held constant. It's the partial, and I think you guys already had partial derivatives, but you're consuming all this stuff really fast. So, and then the partial of y with respect to t is what? What do I get for the 2s part of it?
2.
The 2s, it's all like a constant. Might be an ugly looking constant because I'm taking my derivative with respect to t.
0.
Right. And then what's the derivative of t squared? That's when you know your little kid doesn't understand it. You say, what's the derivative of x squared? And he says 2x. You say, what's the derivative of t squared? And he stares at you. What is it? Come on, this is an easy one.
2t.
That's right. Okay, step 3. You're going to plug everything back into the derivative. You have a piece of paper in front of you to take notes on. I don't. I'm going to erase because I don't want to copy these things to the other page. So I'm going to make some space for myself. I'm going to erase. Are we all caught up? I don't want to erase anything until you're caught up.
You just find the derivative by the first 2 equations you gave us.
Right, they came from up here. Oops. Undo. They came from this guy.
All right. Thank you.
Okay. Okay, good? All right, I'm going to do some erasing.
Yeah, why didn't you just find the partial derivative of like x and y on the t function? Like when we
Hold off. Hold that thought. Now you just plug everything back into the partial of z with respect to t. Wherever there was an x, you're going to plop in the function. Wherever there was a partial of x with respect to t, you're going to pop in those things from step 2. And what I get is a hot mess. If they didn't ask me to simplify it, don't simplify it. Why make another mistake? So x is s times t. So I'm going to substitute this x that I see right here for s times t. And then partial of x with respect to t is s. And then I got y squared. I'm going to drop my 1 now. Partial of x with respect to t is, again, s. And then I have, oh, sorry, instead of y squared, I have to pop in y squared. This is why I get B's and not A's. Y was 2s plus t squared. That's squared times s. And my last thing is going to be below here, 2, it's going to be x times 2y
2 now,
Yes.
like at the, for the ST.
Yes, it's 2. It's coming from here.
Okay, thank you.
And that's your final answer. So I believe, maybe I'm wrong, but I believe what you're asking me is, why can't I plug in the x at the beginning and the y at the beginning and just take the partials with respect to s and t? Was that what you're asking? Yes, you can. And guess what? Stuart has actually thought of that and asked you to do both and show that you get the same answer. Isn't that lovely? Okay. So I did the problems that way all the time. Once I just looked at it and said, okay, all I have to do is, what he's asking is, can't I just put x equals st at the beginning to put y equals 2s plus t squared and plug it in for y. And then I have just s's and t's, and I just take the partials. So I did that for my whole time that I was taking this kind of math as undergrad. I got here today, so it didn't hurt me. But there were problems where this was easier to do. And that's when the functions are really nasty, then you don't want to do it. Or if they want you to simplify something, or they want you to plug in a number into it. And if this thing is really ugly at the beginning, it's not a good idea. But I got through. So it's not terrible if you only know one way. But you're an A+ student, you're not a B+ student. You'll want to do it both ways. You are all better students than I was as an undergrad, 100%. Okay, so take boards, you try it out, but this time I want you to find the partial of z with respect to f. I did the partial of z with respect to t. I'd like you to do partial of z with respect to s. All right,